MagnoVision is an electromagnetic neuromodulation and iontophoresis device used in the therapy of retina and optic nerve pathologies. MagnoVision is a very safe medical device with MDRCE certification. Its effects have been scientifically proven in the therapy of retina and optic nerve diseases. MagnoVision consists of one helmet and one processor. The helmet contains 9 coils designed in anatomical locations to stimulate the retina, optic nerve, and visual pathways. MagnoVision creates a magnetic field intensity of 2000 mg with a frequency of 42 Hz for each 30-minute session. MagnoVision has 2 main mechanisms of action: neuromodulation and iontophoresis. Neuromodulation. Light coming from objects to the eye activates ion channels in the retinal photoreceptors through the visual cycle and opsin proteins. Action potentials occurring in the retina are transmitted to the occipital cortex via ganglion cells, optic nerve fibers, and visual pathways. Degenerative, ischemic, and traumatic pathologies of the retina optic nerve slow down visual neural transmission. In retinal pathologies, the slowdown of visual neuronal transmission causes the remaining photoreceptors to go into dormant phase. In optic nerve pathologies, the slowdown of visual neuronal transmission causes the remaining optic nerve fibers to switch to up mode. Photoreceptors in dormant phase or fibers in up mode lead to progressive vision loss. Each session, MagnoVision creates a 2000 mg magnetic field with a frequency of 42 Hz for 30 minutes. This effect creates external alternating electrical current in the retina, optic nerve, and visual pathways. Electromagnetic stimulation of ion channels leads to acceleration of visual neural transmission. External acceleration of visual neural transmission with MagnoVision reactivates dormant photoreceptors in the retina. External acceleration of visual neural transmission with MagnoVision puts the optic nerve fibers in up mode into on mode. MagnoVision can stop progressive vision loss due to retinal and optic nerve diseases, slow down prognosis, or increase visual functions. Iontophoresis. Intravitreal, subtenon, suprachoroidal, subretinal, and systemic drug injections are used in the treatment of retinal, optic nerve, uveal, and choroidal diseases. Sometimes there is no response to eye drug injections, sometimes a partial response is obtained, and sometimes rapid relapses occur. Applying MagnoVision immediately after eye drug injections leads to faster molecular movement due to the electrical charges of the drug molecules. MagnoVision allows drug molecules to penetrate the target tissue faster and at higher concentration. MagnoVision's electromagnetic iontophoresis effect can provide a faster response to the treatment of retina, optic nerve, uvea, and choroid diseases and reduce the need for boosters. MagnoVision indications: degenerative retinal diseases, retinitis pigmentosa, age-related macular degeneration. Periodically, one session of 30 minutes once a week, neuromodulation effect, or immediately after drug injections. Iontophoresis effect. Ischemic retinal diseases. Iontophoresis. Capillary ischemia. Diabetic retinopathy, PAMM, macular telangiectasia. Retinal vein and artery occlusions. Chronic central serous chorioretinopathy. Iontophoresis. Optic neuropathies. Toxic, ischemic.